So a two-variable linear equation. There's going to be 6 questions on that. What do those 6 questions look like? I might ask you to write a linear equation. I might ask you to write in slope-intercept form. I might give you a line. I might say in this story, write it in standard form, right? So you might see line. I might ask you to do standard form. I usually don't specify that it has to be slope-intercept for all of them. So the easiest way, if you're given an option, do point slope, okay? So with those, so then the next thing you have to do on the final, you will graph 2-variable equation and inequality. So one is going to be shading. That means it's an inequality. So you need to know, oh, is it less than or greater than? Is it a dashed or solid line? Is it going to be shading or no shading? Because if you shade when you shouldn't, it's wrong, right? If you don't shade, that's also wrong. You lose points on that. So there's 2 questions where you have to do a graph. Writing sequences, there's going to be 2 questions. You have to write a recursive and an explicit. Okay? So the third thing you see on the test next week, Monday, or Tuesday, excuse me. So we will take your test, your final on the 19th and 20th. It will be a 2-day test. You'll do part of it one day, part the next day. Interpreting and comparing key features is the next portion of the test. There'll be 4 questions. When it's linear, what I'm going to be looking for is that you are finding or being able to tell me something about the slope of the line and the y-intercept. Those would be key features. You might be asked to explain what did that slope mean? What did that y-intercept mean in that situation? Interpreting key features of our absolute value function. So we have worked with a parent function. It looks like this, y equals absolute value of x. And then we've also worked with our functions when we have it written in this form. So there might be a number out in front here. Well, that's going to tell us both the direction and the width, the m then. The vertex is told to us by the x1 and y1. So you need to be able to tell me, oh, I can look at this and say, this is the vertex. This parabola is going up or down, and you might be asked to graph it, right? So as you are looking at those. The next thing you're going to see on day 1 is your systems part. So just like systems test D, solve real-world problems with systems. There's 4 questions. 2 of them you're going to be asked to solve. So I give you a system with 2 equations and 2 variables, and I will say, solve it. You can use substitution, you can use elimination. Then I'm going to ask you to graph, and it's going to be an inequality. So if you think like on the last test, it was a copy problem that you did. So like it'll be a story problem and ask you to graph that, I believe. It might be where I give you the inequalities, like on the last test also, and then you have to do those. And then writing the equation and solve it. I did scroll down. Okay, so there. So day 2, there's only going to be 15 questions. So the first day, you can total the number of questions that I put, but the first day there's a few more questions because we are not doing the 2-way tables and the statistics part this year on the final. So the first thing you're going to see, solve equations and inequalities. There's going to be 9 questions. If I was looking at your review, I would look at questions 66 to 94. So those are all of solving of equations and inequalities. You're going to have literal equations where you're solving for one variable, like if you're solve for W or X or P or N. You're going to have absolute value where you have to split it and get the 2 answers, or tell me, oh, absolute value equals a negative number, so there's no solution. This is like where you're giving the reasons in the review. Like I will give you all the steps, you just have to write the reasons. So you don't have to write the steps and the reason. I'll give you all the steps, and we'll look at a couple of those from like that remembering if there's a true or a false inequality or equation, that's when you have, if it's true, infinitely many are all real numbers. And if it's false, that's when you're going to have no solution. The next part of the test, so that's the first 9 questions. The next part will be 4 questions. Create an equation and an inequality. This is like the beginning of the year. This is simpler equation. So if you look back at 61 to 65 on the review, this was the one like with the iguana and the gecko, right? It was not a hard equation to write. Some of you made it harder than you had to if you were thinking about that. So I will ask you to write 2 equations only, and then I'll ask you for 2 equations to write and solve it. Again, there's only going to be 1 variable when you do these equations. So it's going to be a 1 variable equation that you're looking at. And then the last part of the test, the last 3 questions that you're going to look at, are to represent and analyze bivariate data. And if you were looking at your review, you would have seen this for questions 35 and 36. And when you look at those questions, that's the standard that's like on the top of the page. It's where I had it in bold. Right? What are you going to be asked to do? You're going to have to first make a scatter plot. So I will tell you the label on the bottom and the label on the side. I'll tell you the X and the Y. Then you have to plot them correctly. So if it's 10, 4, I need to go over 10 and up 4. If it's 1, 6, I'm going to have to go to 1 and 6. So I'm going to plot all those points. I'm putting a point for all of them. You're not connecting those points with a line. It's a scatter plot. Then you're going to draw your trend line. Your trend line does not have to go through any of the data points, but it could. You're going to draw that line. Then you're going to write an equation for the line. When you write that equation for the line, you probably should tell me your points that you're using, and you need to find the slope. Now, usually you're going to start it in point slope, but then you're going to finish with slope intercept. And your slope is probably going to be a decimal, maybe a fraction, but you might get some kind of weird numbers when you look at the scale. So that's the other thing. You're going to look at the scale of these, and when we look at that scale, I might notice that this goes by 50s for a jump, and this goes by 2, 3, by 1, right? So that's going to change if I'm looking at finding the slope, right? Because I'm going to be looking at maybe a rise of 50 and going over 3. Well, it's not up 1. This doesn't count for 1 between here. That counts as 50. So you got to be really careful and watch your scale on your graph. And then you're going to be asked to use the equation. So again, if I was looking at page 35 and 36, that's where I'd say it's going to be almost, or like questions 35 and 36 in the review that you got. From the first line to the second line, what would you say happened? Combine like terms. I'm going to give you a word bank, just like this, for the one question that you have to do, right? So you would go up here and go, oh, combine like terms. Larissa, the next step, 5x minus 6 equals 10 to just give us 5x equals 16. What did we do? What did you subtract? Oh, yeah. We're going to go addition. So this is the addition property of equality. Okay? Grace, we're looking at the last step to go from 5x equals 16 to just x equals 16 fifths. So this would be our division property of equality. So it said, if you notice, all of these have equality, none of them have inequality, so just make sure you're putting them correctly. All right, so we're looking at this next one in 92. What would you say to start us off? Distributed. Okay? Kasha, I'm looking at the next one. What did we do to get 4x minus 8 plus 7 equals 2x to get the second line, or the third line down?
Can you still combine like terms if they're not variable?
Yep, it's still combined like terms. Sometimes I'll have some people say simplify, but it's really combining like terms. It's just that they're both numbers. So our terms are just a constant if you look at that. Okay? Griffin, the next one. Addition, property, equality. Okay. And if I'm looking at the last one, what would you say, Riley? Division property. Now, what if I would have had something like x equals 14 over 21, and then the next step I say x equals 2/3. That's the simplify, right? So it's like giving you this answer and then putting it in a simpler term. That's going to be the simplifier. So that's when I would use that simplify if we are looking at that instead of maybe combining them. Okay? And then don't have any fractions. So the first thing people say is, oh, I can multiply by 9 on both sides to get rid of the denominator. But if I actually want to get rid of this whole fraction on this side, and we're trying to get this f by itself. So we want to find one f, if you think about that. So I could take and multiply by its reciprocal. 9/5 times c is equal to 9/5 times, we had 5/9, and we had f minus 32. And someone said, well, don't we have to distribute that out? Well, no, because 9/5 times 5/9 is just going to give us 1. So we actually don't have to put 1 times that parenthesis. We can just say f minus 32 is now equal to 9/5 times c. The 9/5 times c, it might be easier to change it to a decimal. 9/5, 9 divided by 5 is 1.8. Oh man, that looks a lot easier already, right? I mean, you don't have to keep it as a fraction. You can change that fraction to a decimal. Now, 5/9, why wouldn't we want to do that? Because that's 0.5 repeating, right? That's not going to be helpful for us. So here, I would not want to, but at this point, with 5's in the denominator, I know that that's a terminating fraction, or decimal. So I'm now trying to get f by itself, and I'm going to add 32 to both sides. So I have f equals 1.8c plus 32. Okay? So mx is going to be divided by f, the next one, and p is divided by f. So I now am going to have, as I'm looking at that, m equals, well, the x's here cancel also, so I'm going to have 2n. And I'm going to have, that's a plus 2n, and then equal to p divided by f. But I still need to get m by itself. So if I'm doing that, Jacob, what do I have to do next? Subtract 2n. And does it matter if I put px minus 2n equals m? Or if someone else writes their answer and says m is equal to negative 2n plus p divided p. Does it matter which way? No, we just got to make sure in front of the 2n that it's negative and that the other one is a positive. But I can take either one of these answers. Did you have to divide by x first like Allie did? No, you could have subtracted 2nx first and then done it. Yeah.
Can you have n equals p minus 2nx over n?
Because you should be able to simplify, I would probably, because this would have like this whole thing over x, and that could be simplified, I would recommend doing it separate. If you can't simplify anything, so like if my answer comes out to be something like m equals a minus b all over c, and there's nothing to simplify, there's no c, then keep it all over 1. But if I have like we did, and you can simplify out an X, then you want to do that. Okay? Is that your question too, or is that different? 80 what? 80, yeah. So you can see my work up here for number 80. And what we did was we used the distributive property and got negative 3W plus 9, negative times negative, equals 9 minus 3W. And if you get all of your variables on one side, you get 9 is greater than 9. 9 is never greater, it's equal. So that's the no solution. Even though you're like, oh, I mean, if it would have been this, 9 equals 9, then it's all real solution. But this doesn't say equal, it says greater. And if you automatically put an equal below it, you can just add those in whenever you want. Right? Anyone else that you want me to take a look at?